Hello everyone, nice to meet you again. Welcome to the fourth day's course of SuperMap SMC 5D application analysis. In the last 2 days, we learned about vector analysis and raster analysis. Today, we are going to know about the network analysis. In today's course, we are going to plan a shortest route that can go through all the parks of a city. Now let's firstly take a look at what is network analysis. Let's open our help document and find the network analysis under the technology document. Here we can see network analysis is the process to solve the practical problem by analysis in network model, such as path analysis, service area analysis, or find the closest facility. Or we can also use network analysis in electronic navigation, transportation, tourism, or urban planning, and so on. First, let's look at what is network model. In SuperMap, there are 2 types model: transportation network model and the public facility network model. The transportation network is a network with no directions, in which the commonest is route transportation network. It is often used for the route searching and location finding. But the facility network model is a network with directions, commonly including natural gas pipelines, rivers. Such a network is a directed network, and for example, we can we are going to determine the upstream path from a point to another point to find the source of the population in the river, or timely turning off the valves of the water pipeline which has the drop turns. So here we will use facility network model. And here is the introduction of transportation network analysis. Just like we can use transportation network analysis to solve the shortest route from point A to point B, or we can plan a route which can pass to the most points of the interests at a time. Or we can use transportation network analysis to analyze the coverage or area of the customers of a newly opened supermarket, and also we can use to solve the problem: how can a distributor deliver all these delivery tasks in the shortest time. So this is all about the transportation network. And here we can see there's some basic concepts, and the basic concepts are also used for the facility networks. Then, like the network diagram, both transportation network and facility network contain the network datasets, which are composed of a group of interrelated arcs, nodes, and their attributes. Here is the concept of the nodes, arcs. And in the transportation network, there is a turntable which can store the turning costs. And the facility network that makes the follow direction overview. And here is the network analysis workflow. The first, we need to prepare the network dataset, and then we end the network dataset. Also, the third, we need to set the network analysis environment, then create a new instance of network analysis, such as optimal path analysis, service analysis, and then we add the objects of network analysis to the current map window, and also set the analysis parameters performing the surface area analysis. Just like the performing the surface area analysis, need to set whether the surface radius and the analysis directions start at the service station, whether the service stations are mutually exclusive, whether the analysis uses the turntables, and so on. So, and the last one is perform the analysis and check the analysis results and the path table. Here, so the first is the building the network dataset. This is the basic for network analysis. Because the network datasets has the network topological relationships. Includes the network line datasets and the network node datasets, as well as the topological relationship between them. And here there is the way to construct network dataset. We need to enter the line data or the point data, and here is the parameter settings, split settings. If you have point data, and the line will be splitted by point, and if you don't have point data, the line will be split at intersection. So here is the instance manager, and then the environment setting includes the just like the node ID field, edge ID field setting, and start ID field setting, end ID field setting. Actually, when we build a network dataset, these fields will be generated automatically, and but this just like the node tolerance or the traffic rules turntable edge information field, you can customize. And here is the path guide we provide for users. And so here we can see in the networks analysis, we can do navigation analysis. We can get the navigation from A to B, or route planning, or optimal path analysis. Find the maybe the path is the nearest is the shortest path, or it is the cost and maybe it will cost little time. Also the TSP analysis, multiple TSP analysis. So here we can know location. For you can you can view this these functions in details with this help document, and also the tracing analysis. So now let's go to the desktop to find where is the network analysis. The facility network analysis is under the analysis menu in the 10i variant. Here, structure, network, and the network analysis. Here, this analysis for facility network analysis, and then the traffic analysis. Here, this analysis for the transportation network analysis. So today, we are going to use the transportation network analysis to find a shortest way which can go through all the parks of a city. Now let's see what data we need to prepare. We need the road data, and here we prepare park data. The first way we are going to build a 2D network data set. So let's do it. And we first find here we already have road data of Russia, and we are going to construct the road network dataset. And here we change the split the lines and the intersection, because here we have no point data. And okay. Then let's open the road to the map. Here we can check the road, the network data set composed with line data and just like the edge data and the node data. And also we can open it to check it. Here we can see this this node and the edge ID, the from node to node ID, which the road doesn't have it. So here is the this represents the topology relationship between the roads among the roads and the nodes. So here, because the road data also has large numbers. So here we only select one small city to do analysis. Here with this data we can have a try. Just like we found traffic analysis and optimal paths. Here station, we can add 2 station or 3 station and run it. Here we can get the optimal path. and here we can see the weight will use the length, so the result is the shortest path from station A to station B to station 3. So then we just clear it. So we want to know how to go through all the parks in a city with the shortest route. First, we need to extract parks. Here we and for the route, for this network analysis here, I just select the Rajshahi city. Here we can set the city names to better know which city we are selected. What font set? No. Sorry. I forgot. And I don't like the black, so here it is. And then we change the make the map much clearly. Then we add the POI data. Current map. Here we are going to select the Rajshahi cities parks. So here we are also use special query and select the POI which contains by the Rajshahi city and the name. We only want parks. Where is the park? Here. And here we save the result, save to the Rajshahi city, name park, and create. So here we can see there are 4 parks in Rajshahi city. And now close it. We remove the whole country's POI and only end the parks. Here we can see the 4 parks. Now we can change the styles. Like here we find park. Okay. Here is the 4 parks of Rajshahi city, and then now here we can make the route visible, and now we can going to select optimal path. And here we can right click it and import. We are going to import the park data and the name park, the park's name, the name field is the park's name. Okay. Here we can see the park and the park's name added to the map. There are 4 parks, and here we can also set barrier node. The barrier means if there a road between these 2 parks are repaired, and it cannot go through. So here you can add a barrier node on this road. So this is about the barrier, but we don't know which road are repaired. So here we don't add it. Just every road can go through. Now we are going to we can go run it. Here we can see this route is the shortest route from this park to this park, and now here we can set the parameters here, and we can check here enable path guide. Okay, then we run it again. So here we can find path guide, and we can undock it. So here we can see from start stop, and here walk 561 meters ahead along. Here is the guide from the start stop and to the arrive at this two route node, and to the end, arrive at the end. And here we can see we don't understand the code. Here we can change the environment here. Just like the forward width field, we also use the length field because we want the shortest route. And here we can change the edge infer field. We can change it to name. Here is the road name, and then let's play it. Here, so here it's automatic. So here we can see how to go from one place to another with animation effect. Here then we change the edge road information, and we run it. Here we can see anonymous because some roads have no names. So here we can see if if the road have name, it will show like this ahead along, just like the Nator Road and enter Dhaka Joshua Highway. So here is the then here we get the result of the shortest path planning. We are going to save this road. Here we can see the result is CAD data sets and stored in a temporary data. Here we are going to save it to save the temporary data to existed data. Here we can also new a data set to store the network result. And here we can see there are three CAD data sets, here is barrier, stop, and result. Because we do not have a barrier, so we just store stop and the root result. Here we find the stop and the result. We copy data set and we select all. Settings the target data set source. We select network. And here we copy. Then we can add this up to the count map and make. So if you don't save it when you close the map, and the temporary data will be disappeared. So you need to save it. And then here we can also save the guide result. Here we can also see we can see how the animation has this, and here we can save the result. Do it to equals. Then we're going to find the process. Here is the parse application result. Here we can see there are HTML file and an image file. The image file stores all these pictures and some JS code. Here we can open the HTML with Google Chrome, and here we can see from start, stop, and walk. Here is the guidance information, and here we can see the total distance meters is about 66 kilometers. So then besides here we finish the here we give the result, and we save parts, and can change the total distance, and also we saved the analysis results. So here we can do remember after your processing or do any modification on the map, you better to save this map. And park route. Here just like we close it. Here, just like I said, when we close the map, the temporary data source disappeared. So we need to store this parse, and here we can open it. And here we can see this; it cannot be found, and we can just remove it. Then we get this result like this. So here we can do analysis, the shortest route through all the parks in the city of Rajshahi. Sorry, here The shortest route through all the paths in the city of Rajshahi is from uh, maybe Nano Shah Park to Natural Garden and Resort, and then from here to the modern nursery show center. Then we will go get to the Savannah Park Limited, this park, and the total distance is about 66 kilometers. Besides, we can also have plan from one city to another, which if you want to know how long from Bogora to Rajshahi city. Here we can end a point at the Bogora and then end station at Rajshahi. Then we can also use the optimal analysis to get planning. Today's result are all based on the distance, the shortest distance. Also, if you have the time fields, you can also best set the weight field at the time. So it will be get planning using time cost. Here I just showed from Neogong to Rajshahi or Bogora to Rajshahi city and Pavla to Rajshahi city. I get the results is that the shortest route from Bogora to Rajshahi is about 121 kilometers, and from Pavla to Rajshahi is about 78 kilometers, and from Nogin to Rajshahi is about 90 kilometers. So you all can have a try to plan a route. I think let me show you here. Let me show you how to plan a route from one city to another. Here we just also select optimal path and then station. Here we just and a station we want to from Bogora to Rajshahi. So we end the two stations, and then here we also can set the enable path guide and run it. Here we can get a planning route from Bogora to Rajshahi, and here shows the. Here we also change the edge field. Change it to the road name and run it again. So here we can see the details from Bogora to Rajshahi, and every road, the distance of every road, and also you can save it. the second one, and I open it with Google Classroom, Google Chrome. Sorry. Here we can see the total distance is 122, about 122 kilometers, and each every road. Then also you can save the stop and the result. You can save the stop and the result to existed data source, and even though you close it, you can add so that's it. So you can add many cities, give many cities a route plan. So actually there are also another network analysis. Just you can find the TSP path service area analysis. These are often used to planning. If you have these questions, you can have a try using these functions. And I think that's all about the network analysis. Thank you for your listening, and tomorrow we're going to our last course about statistics. Have a nice day, and look forward to you in the tomorrow. Thank you. See you.